Hello, welcome back. Now, here we shall discuss the relation between simple random sampling or comparison between simple random sampling and cluster sampling in terms of their efficiencies. And we shall discuss two expressions for relative efficiencies. One in terms of the intra-class correlation coefficient rho, and the other in terms of the mean square between clusters and mean square within clusters. Okay, first we shall discuss the relative efficiency in terms of intra-class correlation coefficient. Now here, for making comparison, you should remember that in cluster sampling, we are sampling small n clusters, each of having capital M elementary units or elements. And naturally, such a cluster sample mean should be compared with the simple random sampling of the same sample size. That is, the sample size should be small n into capital M. Okay. So, we have the variance of cluster sample mean as approximately equal to 1 by m into 1 plus m minus 1 into rho into s square, where rho is the intra-class correlation coefficient and s square is the mean square, overall mean square. Okay. And when a sample of size nm is considered, we shall have the variance of an equivalent sample, simple random sample mean, variance of I bar is equal to 1 by nm minus 1 by nm into s square. In usual simple random sampling of size small n, we will be using 1 by n minus 1 by n into s square, but here we are using nm and capital Nm, because the population is considered to be of nm, capital Nm elementary units, and the sample is of considered to be small n into m elementary units. So the comparison of this variance should be with this variance. Okay. And you can see that this can be simplified as 1 minus f by n into 1 by m into s square. See? Because 1 by m can be taken outside. And if we are using n is large, then it is having an approximate value 1 by n into capital M into s square. So these two things can be compared for getting the relative efficiency E equal to the ratio of variance under simple random sampling and variance under cluster sampling, which is equal to this expression. And on simplification, you will get 1 plus m minus 1 into rho to the power of minus 1. Okay. So this is the expression for relative efficiency of cluster sampling in terms of the intra-class correlation coefficient rho. Okay. And as a remark, I have added that if the intra-class correlation, relative efficiency is given, intra-class correlation rho can be computed using the transposition of this formula. Okay. And this may be useful for practical purposes. Okay. And then another issue is that how the sampling variance of cluster sampling will be estimated. And for making estimation of the true variance of y bar by double bar, that is 1 by f by n into capital SB square, we can use small sb square as a unbiased estimator of capital SB square. Why? Because the difference of theory in simple random sampling and cluster sampling is that in simple random sampling you are selecting by SRS the elementary units, whereas in cluster sampling you are selecting clusters. Okay, so the same theory you can extend to here, so that the expectation of small SB square equal to capital SB square. Okay, so in this expression variance of y double bar equal to 1 minus f by n into SB square, for making an unbiased estimate of this variance, this capital SB square can be replaced by its unbiased estimator small SB square. Okay, so the variance estimator is plainly variance of y double bar v small v of variance of y double bar, that is equal to 1 minus f into small SB square. Okay, so what we are doing here is we are just applying the theory of simple random sampling of units to simple random sampling of clusters, that's all. Okay, that is regarding the estimation of sampling variance. Okay, and the third issue which we shall discuss now is how to estimate the population total capital Y. And once the population mean is estimated, what you have to do? You have to multiply that estimator with the total number of units in the sample. And here in cluster sampling, you know, the total number of units in the population. So in cluster sampling, you have capital N into capital M units in the population. Therefore, the estimator of population total under cluster sampling is equal to equal to this y hat c, that is equal to nm into small y double bar. And of course, the variance of this estimator can be computed like this. Variance of y hat, estimated variance of y hat c, that is equal to capital N square into capital M square into 1 minus f by n into SB square. Oh, okay, all these things are immediate results. Okay. Now, one more issue we are going to discuss is that how the relative efficiency can be computed in terms of the overall mean square capital square and mean square between clusters. And you can see that this relative efficiency of cluster sample mean over simple random sample mean is equal to the ratio of the variances, and as per the earlier expressions which we have proved so far, that is equal to capital S square divided by m into SB square. Okay, so you can see that the relative efficiency increases as SB square decreases. Capital S square is fixed for the entire population, and whenever the clusters are so formed in such a way that the mean square between clusters is smaller, then the relative efficiency will be higher. Okay, so that is another conclusion regarding the cluster sampling, right? And again, you can extend this result. This expression can be further improved by taking the expansion of capital S square. And here you see capital S square can be expressed like this, nm minus 1 into S square, because capital S square is this, and nm minus 1 into S square is equal to this, and usual algebraic manipulations will give you this expression. And here you shall define capital SI square is equal to 1 by m minus 1 into sigma over j equal to 1 to m yij minus yi bar. What is this? This is the mean square of elements in the ith clusters. Okay, and if you are taking the average of this, you can denote this by SW square. SW square stands for mean square within all clusters. what is the difference between SI square and SW square? SI square is regarding the ith cluster and SW square is regarding all clusters. So SI square is the mean square within ith cluster and SW square is the average of all such SI square. So this can be called as mean square within all clusters. Okay, and now you can again represent this nm minus 1 into s square equal to this, and using this expression the relative efficiency can be made to be equal to this last expression. Okay, so you see that the relative efficiency is given in terms of the mean square within clusters as well as the mean square between clusters. Okay, so we have discussed so far three expressions of relative efficiencies, one with the relative efficiency in terms of intra-class correlation coefficient, a second with the relative efficiency in terms of the overall mean square and mean square between clusters, and the third one is the relative efficiency expression in terms of between cluster means and within cluster means. Okay, and these are regarding the cluster sampling with the equal size. Equal size means all clusters are having capital M elements. But practically we have already argued that such situations will be only ideal, and in practice we will have clusters with different sizes. So naturally we have to develop a theory for clusters with unequal sizes, and I give you this theory of clusters with unequal clusters. Capital M പകരം capital MI. Capital MI stands for the number of elementary units in the ith cluster. And you refer to Cochrane and some other books which you can download from internet, how the cluster sampling means will be characterized. Okay, and I leave this as an assignment for you, and you go through the theory of unequal clusters, and if possible I shall give you an additional note on these things later. Okay, thank you.